They currently serve as the STEAM Outreach Coordinator and Instructor at the Atlas Institute at University of Colorado Boulder. Dr. Z has previously investigated snake vision using behavioral neuroscience and gaming technology and now studies STEAM education. Their research team uses neuroscience and social engagement to create inclusive at-home STEAM learning tools that incorporate current STEM discoveries and artistic practices for middle school learners. Their team is using these tools to explore approaches to cultural responsiveness and establish frameworks for cultural inclusion and belonging outside the classroom. So with that, I'd like to welcome Shaz to you and invite them to begin their talk.
Thanks to you all for your patience. Thank you for inviting me out here. I'm really excited to be here. And I'm also really grateful for that introduction. Everything is really awesome. I've had a really wonderful time, just everything getting set to come here. So today I'm going to chat a bit about the expanse of work that I've done. I popped by yesterday and spoke with a few folks and ended up adding a few more flying snake slides, because who doesn't want to see flying snakes? They're the coolest animal on the planet. Yes, I said it, and I'll say it again. All right, so to get started, I just want to talk a bit about who I am. And if there's one thing you have to know about me, is that I love snakes. That's my ball python trouser. And when I say I love snakes, I mean I really love snakes. Like, I'm happy when there's a snake on me. And my love for snakes really shaped my career. It shaped all of the research questions. When I started grad school, I wanted to study visual processing in rattlesnakes, so because the overlap of infrared and visual spectra. But that didn't work out. I ended up studying mosquitoes instead and landed this super sweet postdoc where I got to work with flying snakes. There's one there sticking out of my hair. I was quite content in there. And so I'll talk a little bit about that work and then how snakes brought me to outreach. But I'm not just a scientist. I'm not just a neuroengineer, someone who likes to build tools that help us explore how the nervous system works. I'm, like every other person, a very broad and multifaceted person, and I have a long extended career in performance as well. I've been singing since I was a child. I've been in choirs and bands. I've sung at the White House. I've shared stages with very famous national acts. And then I recently transitioned to choir performance, both recreationally and professionally. And this also has shaped my career. I kind of felt a tension between working in research and then loving being on stage throughout my entire career. And I wanted to find someplace that enmeshed both of these sides of me that were so important and motivational. So I don't have my presentation slides, so it's going to be a little bit clunky, but we'll get there. Okay, so in this talk, I'm going to start out by going over what I did before I got to Atlas, before I got to CU Boulder, talking about flying snakes and how they are kind of the kernel of outreach. I don't think I would have gotten into outreach as aggressively if I hadn't been working with flying snakes. And then I'm going to transfer to talking about what I'm working on now by just talking about problems that we're facing around inclusion in education, in K-12, as well as higher ed, and then talk about my proposed solution, which I'm actively testing, which is to use comics as a mechanism of communication and storytelling. And talking a little bit about the history and evolution that goes into storytelling. And then I'll close off with tips and practices. Oh, I think, sorry. All right, I'm not sure what's happening. I got a message, but okay. So I'll close off with tips and practices. If there's time, which I'm not sure, there'll be an exercise. I really like people to have something to take away with them. So hopefully you'll have an exercise. If not, you'll have some very informative slides that you can take with you so you can improve your communication and teaching practices as well. So let's just dive right in. So this is an image of Chrysopelea paradisi, the paradise tree snake. And I spent 3 years studying their visual behaviors in the Soha lab at Virginia Tech. And we worked with 2 species of Chrysopelea. One is the tree snake that you see there, and the other is the ornate
tree snake. They are large, irascible, and don't like to fly, so I'm not really going to talk about them. I am going to focus all of my work on the paradise tree snakes because they're so pretty. And one thing that you'll notice, I really love form observation. So you'll notice that they have really big eyes along with their beautiful jewel tones. And one thing that stuck out to me when I first started to work with them was that they act a lot like birds. They have an orienting behavior that's very staccato and like saltatory, much like birds do. So they'll kind of quickly move their heads around. And they also see the world a bit like birds. And I mean this both figuratively and literally. So here is a wild-caught paradise tree snake in Borneo. When we catch them, we could basically set up a branch on a cherry picker or scaffolding, and they naturally want to go to the edge of the branch, and then we kind of tap it to mimic predator behaviors, like there's a predator on a tree, to entice them to glide. And so this is the last glide that this particular snake is doing. We're releasing it back into the wild. You're going to see it spend a considerable amount of time assessing its environment. This is what we call a J formation. It's a particular posture that they take right before they jump. They'll launch its posterior body, go into a ballistic dive, and then right around here is where all the action is going to happen. It'll go into a glide at the very end. And I will show it a couple of times because it does take, you have to kind of look at these enough to see what's going on. And I chose this video, yeah, we're downloading this from the internet, because it spends a really long time looking around and assessing its environment. And this is an exceptionally long period of time, but they all do have this at least some period of looking around and judging where they're going to go. And then it dives, it doesn't do it justice. Maybe if a replay, once it's all downloaded and buffered, yeah. All right, no. Then it'll launch. Yeah. I am happy to share this video around if people want to see it afterward, or we could come up and you can see it on my laptop where it will be smoother, because we're, well, maybe, no, tragedy. Well, they're cool and they glide a lot. But one thing, so I came into this lab, they wanted to have somebody that looked at kind of control and decision making in these snakes. They were doing all of these glides. They have all of these, a whole suite of strange behaviors that were just pouring out questions. But they are also pretty rare. So they're found in Southeast Malaysia, Southeast Asia. So from the Philippines, all the way up through the southern tip of India and parts of China. And so they're pretty rare. There's 2 labs in the United States that have them. There are very few zoos that have them. And so there's not a lot of data on how these organisms behave. And so before I could do any sort of control work, I ended up having to characterize their visual systems in a general way so we know what to build for that system. And so you can see they have these big, beautiful eyes. You can note this is a head-on image, right? So there's some amount of binocularity because you're able to see both eyes very clearly when it's forward-facing, which is also pretty rare in snakes. You don't see that kind of thing very often. And so in the first few weeks when I started in the lab, we happened to have a snake die early in the morning, and I said, stick it in the freezer, I'm gonna dissect it. And that's exactly what I did. And so here's the dissection, that's the whole brain. Here's the olfactory lobe, this is the front of the head, left an eye intact so you can see the scale of how big these eyes are relative to their brains. And generally in neuroscience, if you spend a lot of energy, developmental energy, and tissue on a sensory organ, you're using it a lot. And this is also complemented by developments in the brain. So when I sent this to the vets that we were working with, I had this very reassuring, it was like when I saw this, I was like, holy crap, that telencephalon is huge. And then I sent it to a vet and she was like, whoa, that's so lobular. I'm like, I know. It was this really awesome moment of just like, yeah, this is weird. So this region right back here is the telencephalon. This is basically the equivalent of our occipital lobe. It's where a lot of visual processing happens. There's a little bit of sensory integration that happens there as well. When we look at this in comparison to another highly visual snake, this is a western diamondback. you can see that in comparison, it's a much bigger mass, it's a much bigger area, and it's more well developed, which means we're spending a lot of developmental energy and a lot of tissue, which is expensive neural tissue, some of the most expensive tissue in the body. So we're spending a lot of energy making this very defined, very highly developed region. And so we can compare the two there. You can see that it's a lot bigger. And you can look at it again without, just so you can see for yourself. So that just got me really excited. I said, okay, they're doing a lot of work with their visual system. So let's see exactly how they're interacting with the world, and let's get some characteristics about that system. So one of the first things I did, one of the most accessible bits of information, is calculating their worldview. I don't like to do invasive work, plus they're really rare. There's about 50 of these in the country that we know of. So we're not really willing to like put electrodes in and sacrifice to make sure that, sacrifice the animal to make sure that the electrode is in the right spot and all that gory stuff. So I did this by using external measurements, which I'll talk about at the end. And I was able to assess their field of view. So we're looking at their horizontal or azimuthal field of view. That's what they see around like the lateral or coronal plane of their head. This triangle represents where their snout is. Anything that's red is binocular. You can see both eyes. Anything that's white is monocular. So you're seeing one eye at a time. And so they have these really big radial views around their head. But surprisingly, and very uncommon in snakes, they have a pretty sizable binocular region. And so we're seeing both the male and the female together. So the female has a much smaller binocular region. The males have a much larger binocular region. And so we don't know very much about how these animals behave in the wild. We don't know much about their local ecology and habitats. All good. But we can compare these to different modes that we see ecologically. So if you are a predator, and the more apex a predator you are, the less likely you are to have surround view, the more likely you're going to have a forward-facing field of view with a large range of binocularity, so you can target and aim and strike and attack. If you are a predator, like we see with a prey, lower to on the food chain, you're more likely to have this surround field of view, like we see with the pigeon, and a very narrow binocular region. Right, and then we see in between, we'll see a variance of this. So humans we're not quite apex evolutionarily, but we are pretty close, right? And so we spend most of our field of view is focused facing forward. And so when we look at this and compare, we can see that these tree snakes are somewhere in the middle of the food chain. They get eaten a lot, but they also eat a lot. And this is in line with what we do know about their natural history. And so we see that their vision differs with their body size. Females tend to be bigger, males tend to be smaller. That changes how their eyes and head interact, which affects their field of view. And this suggests that males and females have different lifestyles, which is certainly confirmed in captivity, but we don't really know what's happening in the wild. We do know that our males are more active. There are more avid flyers. Whenever we're doing our flight trials, we're pretty much only using males. There's like 1 or 2 females that can glide, but the males are the ones that are doing it. And it's nice to see that their visual field kind of confirms that this isn't just chance, this is a strategy. And so this work was done by, I love toys, I love gadgets, I love games. So I took these snakes and I scanned their heads with tape over their eyes to protect it. Then I made a 3D model and I basically shot lasers at that 3D model to see which lasers would encounter one eye, both eyes, or no eyes. And that's how I developed this field of view. So using Unity and 3D scanners and a very, very awesome undergrad. Okay, so I spend a lot of time just observing and looking at these animals and trying to figure out, where do I start? And they have a suite of really funky behaviors, and I'm going to show you 2 right now. I'm working on papers for both of these.
The first is the head wag, which you'll see here. It happens in the wild, it happens in captivity. It's this lateral oscillation of the head. So as it's moving forward, it's looking at a gap, it's trying to assess some sort of challenging spatial movement. And so it does this lateral oscillation that you can see is rather slow as it's looking around its environment. So we call this a head wag. We see it in a number of other species. We actually see it in sister taxa that all live in the same environment as well. So there's something about their habitat conditions that lend themselves to doing this behavior. And so one of the things I investigated in my time there was why the heck they're doing this. And so we saw this come up in two different experiments, completely separate, not planned. We were just like, oh, yeah, they do it there too. So one is this gap crossing task that you see outlined in purple at the top. So we had two branches, they like to go across. We we're trying to determine in that project which behavioral strategies worked based on a challenge that we give them. So how far of a gap and what kind of behaviors do they use to get across these different size gaps. And so they would do a head wag there. And then as I was characterizing their visual acuity, so how fast they can see, how finely they can see, I used an optomotor drum. This is a rotational field of view. Rotational vision does not offer distance information. So while they might be head wagging to induce motion parallax, where things that are closer to you move farther than things that are farther away, we cannot get information about distance if you were to do that in the drum. And they consistently did it. The behavior didn't extinguish. So if they were trying to get information, they would have eventually stopped because it doesn't give the reward, the goal that they were looking for. And we did hours and hours and hours and hours in this drum, and they always did it. So there's something else going on. And what we suspected, where we basically ended up, and I apologize if I couldn't find the slide, is that this is a multimodal behavior. They use it for different purposes in different contexts. So in the gap crossing task, they use it to induce motion parallax to determine distance, how far away is my goal, what behaviors do I have to engage in. And in that condition, they had about a 0.2 hertz oscillation. So when you saw that video, this very slow wag. When we saw it in the optomotor drum, and I'm sorry for the video, I can pull it up after whatever you want. What we suspected then is visual camouflage. So they spend a lot of time in trees among leaves. If all of the leaves are moving and you're not moving, you stand out. So you move your head and now you're blending in behaviorally. And in its condition, we see a much faster oscillation. So it's an order of magnitude faster. So definitely distinct behavior, a distinct property, kinematics of that behavior. And we see, so ultimately we think that they're doing this for both purposes and changing that behavior to suit that purpose. And we see this sort of camouflaging in other species. So it's probably not going to show. We're going to videos are playing. Yeah, that's not even gonna work. Okay, there's a garter snake in that video. It's moving through and it's shaking its head every so often and stopping. And it's also a rather fast oscillation like we saw in the drum experiments. And then probably one of my favorite behaviors is a tongue stick, where they'll flick as they are on the preceding branch, and then they'll just keep their tongue stuck out without oscillating it as they go across this gap. As they get to the other side, they'll actually start to oscillate and then tap the surface with that tongue as they get there. So fortunately, it's a nice static behavior. So even though my video quality is terrible, you can get the idea. So also happenstance, right around the time when we were getting the data on this tongue stick, so we were measuring how far they extend their tongues and for how long, and when they oscillate and when they hold it still. As that data was coming in, it was right around the time when I was finishing up that field of view data. And I noticed that they have this little blind spot just in front of their snout. So the shape of their head and the way that their eyes are oriented, they have a little gap just in front of their head where they can't see. And if we look at the average distance that they're extending their tongue, and this is the scale. No, it didn't draw it. Well, it fills up that gap. I don't know why that isn't there. A little disconcerting. I did not touch this slide. But the tongue fits in, I mean, it comes up to about there. It's a really remarkable match for how well it's filling in that gap. So we're hypothesizing that they're using tactile information to fill in the gap when they're doing this risky behavior when their visual system can't provide that information. So lots and lots of these dynamic behaviors. So altogether, we see a pretty curious collection of these behaviors. So first, they have binocular vision, which is generally rare in snakes. They don't have a phobia, which is sad because a lot of their clade, their sister taxa also have phobia, which I was really excited. God, let there be a fifth species. Nope. They have these dynamic visual behaviors. So the head wag, which they use for both behavioral camouflage and to get distance information. And they have a tongue flick, which allows them to fill in information gaps in one modality with another sensory modality. And then I didn't talk about it here, but they also do overhead tracking. So if there's a plane that's flying overhead or a bird that's flying overhead, they'll actually lift up their head and follow it. And their vertical field of vision is tilted, it's biased upward, suggesting that a lot of their predators come from above. And so they're adapting, they evolved to have this upward vision. On other data that I'm not going to go into for sake of time, they have a surprisingly low light sensitivity. So when we start to see behaviors, it's around dusk, like twilight levels of light, where they start to tend and actually have pretty high acuity behaviors at these very low levels, which is unusual. And then they have broad tuning. So usually when we see predators, especially, we'll see a peak distance that their visual systems are kind of tuned in to, like really defining. Like in hawks, for example, they're on the order of like I think it's like a third of a centimeter that they can separate, and like all of their visual system patterns are kind of tuned to that distance. Not the case with these. We're kind of expecting to see nice sharp tuning curves in their visual characteristics. They were basically flat, and was a stumper for about 6 months. It was like, I don't know what I'm doing wrong with my calculations, and I was like, I think this is actually the data. So we actually figured, along with, we're just seeing a lot of this dynamic behavior. And so while they are diurnal and they're canopy dwellers, they also spend a lot of time in cavities. So they're going through these very drastic and dramatic visual environments as they go through their day. And their visual system has been clearly adapted for that. And if you want to read more about their acuity and sensitivity, the head wag and tongue stick papers should be out next year. And then if you want to learn about this general background things and the work that I did with the scanning, I also ended up making a VR setup for that, which was fun. That's all in their paper that came out in 2020. Okay, so when I'm talking about snakes, whether it's to scientists, whether it's to the general public, this is the question that I always get. Like they think I misspoke. And they want to go, like, rub that back about me again. Every single person that I've ever spoken to is just like, wait, what? They fly? And so it led me, the abundance that I ran into it just got me thinking about, okay, well, what's happening now with this human snake interaction that I keep bumping into? So this juxtaposition of flying and snakes automatically begets some amount of curiosity. What the heck is going on? And I break it down into 3 possible causes. First, it's an unexpected combination. You don't hear flying and snakes in the same sentence unless you're talking about snakes on plane. It's mechanically unlikely. How do you turn a rope into a wing? That's a really, really difficult biomechanical task. So if you're thinking about body forms, if you're thinking about the dynamics, you're like, how the heck are they able to do that? And probably the response I get the most is, it's a threat. Every time I tell people like, oh, they fly, oh, no, get those away from me. That's usually the reaction that I get. And that's because humans and snakes, well, primates and snakes have this very long history. So sometime way back, hundreds of millions of years ago, when prosimians separated from simians, there was some event that happened between snakes and simians. Lemurs, not afraid of snakes. all monkeys and apes have a fear of snakes, innate. Don't have to train them, don't have to show it to them. And our visual systems are tuned to snakes. We're very, very good at detecting the patterns that we see on snakes. We are very, very good at detecting the motion of snakes. The thing that people usually say creeps them out the most is the way that they move. Same with spiders, right? So we're tuned, our visual systems, our nervous systems are actually tuned and evolved to detect snakes. So we have this very close relationship with them, whether we want to or not. And people want to know about it, even if it's just be like, how do I avoid this? I need to have more information so I can keep this away from me. And so as a result, we find out that snakes are transcultural. And I'll show maybe one just for the sake of time. Nice. That there's lots and lots of examples of reverence all around the world, spanning back a huge span of time. So we'll start in Benin, in Ouidah, Benin. So this is a snake temple in Benin. In the 16th century, there was a war, basically when the Benin boundaries were being formed. There was one group that did not want to join Benin, and the king of that particular group is said to have been protected from capture by snakes. And so as a thank you and an honor, they built this temple. They feed all these ball pythons. It's in their natural distribution. And you can go in and hang out with some pythons. They'll put them on you. You can hang out with them. There's all these statues that are in honor of them. And this dates back to the mid-1600s. In Norse mythology, there is a god, I cannot pronounce the name, that is said to wrap around the midwind, and it is a representation of both chaos and order. And this dates back to, this is where I get my notes, I think it's like 380, so it's pretty old. If we keep going back, in Mexico, Teotihuacan, this is a temple of feathered serpents that's about 300 BC. In India, we have the temple of the Snake King, where there are over 100,000 drawings and 30,000 carvings of cobras, and this is 300 BC. And if we go back, probably the oldest, earliest information that we have about snakes, it comes from the Greeks. Where we have the Ouroboros, right, this symbol of fertility and renewal, and then gorgons, of which the most famous is Medusa, this snake-human hybrid deity, right? And this goes back to 14th century BC. So for a long time, we've been telling stories, making shrines, and having this reverent relationship with snakes, which comes to today, right? So this long-standing history is evident today, and this is one thing that really caught my eye and really captivated me. Is like, man, we all share this relationship with snakes. So regardless of what culture you're going to, I can talk about my science and it'll mean something to you. And so I got really curious about what are these mechanisms of curiosity? How do we get people to be engaged with the stories that we're telling? And what other sources, like we have snake plus flying, but what other combinations and tools can we use to evoke that curiosity? And then once we figure that out, how do we apply that toward anti-racism, anti-classism, and other justice works, right? How do we use this to get toward equity? And those questions absolutely took over my brain and brought me to becoming a STEAM communicator, which is what I do at the Atlas Institute, as well as the full professor shenanigans. All right, so here's where we are. I'm going to try to get through this as quickly as I can. But basically, as hopefully common knowledge, we have this disparity that has just been persistent. It is an annoying, complex, and nagging problem, where if we look at performance in K-12 and even in higher education, we see this separation of performance over and over and over again. It is very reliable. So if we get familiar with this graph, this main line is basically the average. It's what is expected on annual standardized tests for performance. Anything above this graph is above average, and each number refers to a year. So if you have a score of 1, you're performing about a year ahead of your classmates. So up to 4 years ahead. And then everything below, we're now performing years behind expected or behind your classmates. right? And so we're seeing, if we look across income alone, that there's this really tight trend where the more disadvantaged you are, the more likely you're going to underperform. And there's lots and lots of reasons behind this, from funding, tax money, what goes into these different public schools. So each circle here is an individual school district, and they're looking at the performance across school districts all across the US. So now, if we filter this data and we start to look at not just income, but race as well, we see that it gets even more disturbing, where white students are most likely to be affluent and most likely to be overperforming or performing above average expectations, and Hispanic and Black students are more likely to be low income and underperforming. So we see this compound. I'm only talking about race and income, but this interaction happens with all sorts of different identities, whether that's physical ability, cognitive abilities, gender, sexual preference, all sorts of things are rolled into that. But I'm just using this for sake of clarity here in brevity. So we have this achievement gap, which is usually measured by comparing what we call mainstream, which are people who tend to be in the center of this wheel of power. So we're looking at different traits and then how they are, the severity to which they are marginalized on that radial axis. So if you're closer to the center, you're more privileged. If you have traits that are on the exterior, you're more likely to be marginalized. And so the practice is to compare the traits on the outside to the traits toward the inside. Right? And so we see this difference in academic performance basically across that entire wheel. And we, of course, know that this is a result of systemic issues. But what's frustrating is that even studying this is compounding the problem, because now it has established that there's this gap. So if you start to talk about the mainstream performance and then ask about the marginalized performance, automatically people are going to go, oh, it's lower. Right, so it builds in the stereotype. So there's a lot of kind of complexity of problems just in identifying the problem itself. Right? Love wicked problems. And so we're noticing that these gaps persist. There's been, 2 decades of very, very dedicated, very, very broad work, a lot of interventions, a lot of different practices, got a bunch of slides I can talk about that go into why, what we've done and why, but we're not seeing too big of a change. So we're looking at these spans of about 20 years difference. So on the left, this is comparing Black and white students in science performance on standardized tests in 4th grade, 8th grade, and 12th grade. And on the right, we're doing the same with Hispanic and white students. So we see this persistent performance gap that is lessening, but it's not really going away despite hundreds of thousands of people doing due diligence. So what is kind of there to me that goes, we're missing some source, we're missing some mechanism that we're not really taking advantage of to solve this problem. And I just go, well, what if it's how we're telling our stories? What if it's how we're teaching these students themselves? And this lines up with cultural differences. So how we tell stories varies wildly across cultures. So here I'm showing examples of different types of song and spoken word. So in all throughout the Sahel region, this is basically Central Africa. You have griots, they've been around way before colonial times, and they tell stories, histories through song. In the Caribbean, there's calypso. So the very popular song Deo, Deo is all about working overnight. It's night laborers wanting to get a break and relief and just dealing with unfair work conditions. Right? So this is how they're talking about social issues. And then in Arapaho cultures, there's a lot of oral stories, usually accompanied by song, if not a song themselves. And then similarly in Hawaiian and Polynesian cultures, you have dance as a form of telling stories. In China, you have Piying, which is shadow puppetry. It's a way of sharing history through basically play enactment, puppetry enactments. And then throughout some regions in the Middle East, you have Zahal, which is like spoken word, or almost like song and spoken word. It's kind of in between. Sadly, there's a sound. Love the emotion. And in our country, we tend to think that these are just ancillary. They're not really the main way that that communicate, but in truth, it's really a central form of communication. And then one of my favorite forms of storytelling, this will work out, is visual vernacular, which is popular in deaf and hard of hearing cultures. So we're not just thinking about regional spaces, we're thinking about social spaces as well. And it's not sign language, right? It's an interpretation of Then cut it off. But there's so much information here. So what's the video about? Yeah, so no words, right? It's all through expression. And so there's many ways that we're communicating with each other all around the world, all across these different cultures. And so if we're telling stories differently, then we're learning differently, right? And this is also confirmed through research. When we ask groups to self-report how they like to educate and interact with each other, we see that it varies across these different cultures. And so Mexican Americans report using a lot of interpersonal relationships, a lot of conversations as a way of educating. In African American cultures, there's a lot of oral and physical, right? Dance, spoken word, and rap. And then collaborative discussion. And then in Native American, there's a lot of visual information. It's a lot of dancing and movement as a way of communicating. And so these learning styles, it's important to keep in mind that they are not, we don't look at this and go, okay, well, every time I teach a Native American student, I'm going to do something visual. It means we expand our toolkit so that we're touching on all these different styles. And so typically when we look at, we have some sort of assessment, we go, okay, we know what our average is. This is the thing that happens the most often. This is the thing we care about the most, right? Especially scientists love that. But that's damaging because it ends up excluding all of the people that are on the wings of that bell curve. And so instead, what this is suggesting, what this work is suggesting, is that we need to consider all of the options that might come up and leave that open for students to kind of access the places where that coincide with them best. And finally, if we ignore these cultural effects, the cultural differences, there's measures of depressed learning, decreased interest, and especially in engineering and science topics. I'm going to skip over this so we can get to the good stuff. But it's just summarizing everything I pretty much just said. And the key point here is that we cannot separate motivation from culture. It's the same. We have to start thinking and including in this and teaching in this multicultural way. And storytelling is the tool, the engagement, storytelling is the tool to get to engagement, right? Get people involved and interested. And storytelling isn't just something that comes across, much like with snakes and snake reverence that happens globally. Storytelling happens globally as well. I argue that this might be a synapomorphy of humans because no primates were really telling stories, at least there's evidence of it beforehand. And this is the oldest known painting. It's 45,000 years old in Indonesia. It was made with ochre. And there's a bunch of different tools that were used here to make this, right? So it wasn't just somebody doodling. This is in a cave. They worked by torchlight. There was an effort. There was a specific effort to get to it. And these handprints, by the way, they think they took the ochre and put it in their mouths and then sprayed it to make this like outline. So there's evidence of play with media and exploration with media. And what I thought was interesting is that the researchers said, you know, there wasn't a definition, it was a sense of art. You just know it when you see it. So again, we're talking about this thing that kind of gets to something that's evolution and that's innate within us. So let's use this tool to get to actually engage people to engage with our work. Okay, so looking at the time, I want to talk about this generally. So I'm looking to apply cultural responsiveness. So this is one of the tools that has come about that has extensive evidence of efficacy. So it's not just a one-off intervention. We see it over and over and over again, increasing engagement, increasing persistence in STEM topics, increasing performance in school. And so it has basically 3 goals. One is to have academic achievement, right? So any student is capable of learning. Cultural competence, so not just learning about the topic, but how the topic interfaces with their everyday life, right? And then socio-political consciousness, so using the classroom as a way to teach students about the world around them, about the status quo, so they can manipulate and work with it as is needed. And so we have a huge number of outcomes from CRP. It's been used for about 20 years now, so there's lots and lots and lots of data at this point demonstrating its efficacy. So how can we leverage storytelling to create inclusive STEAM education? Let's get this slide. 17 minutes left. On shape of topics. Okay, so I came at this just going, all right, we're visual creatures. The first thing that we did, and the evidence that we have is painting, is drawing, is art. Is there art without culture? I don't know. Can you have that? And so we are making this neuroscience comic that incorporates a lot of our culturally responsive pedagogy. And so we're using this old form of storytelling. It also has sequential explanation of processes. Comics also have sociocultural value. Here is a comic fan. Any comic at any point in your life. So it's something that means something. And then it also opens up this fantasy world of superpowers, which we just keep getting closer and closer and closer to with the advances of technology and engineering. And so this story follows 3 students who are multiply marginalized identities. They're in a low income area. They get superpowers, and as they get their superpowers, the readers are learning about neuroscience and basic science as well. And so this hits a number of applications of CRP, like fostering inclusion, supporting a positive attitude by having learning style flexibility. I'll talk about that in a second. And it enhances meaning because now it's taking STEM and placing it into their cultures in a format that is attractive to this age group. And so we worked on a couple of things. There's a lot of thought and care and detail that goes into this. And so we're including cultural differences and important differences at the base level. So my team is very diverse. So this is work by my grad student Shreyasi, undergrad Arba, and my co-collaborator Harley, who's my lead artist and partner in this whole project. And so we wanted to talk about texture and how hair texture interacts differently when we're talking about static charge. So there's this very canonical rub your balloon on your hair, stick it on a wall, or pull the balloon away and your hair sticks to it. Curly hair is going to behave differently than straight hair. And for years, I always wondered what would happen. I always had my hair in braids when I did those experiments at school. I couldn't access that part. I couldn't have that internalized experiential knowledge. And so we're trying to dig that in now and expose students to how these differences might happen across different hair textures. And then we carry this through into activities. So the comic is interactive. And so we get them to not only practice STEM skills, but they're also putting this knowledge into practice as they're reading and interacting with the story. And then we also are including higher concepts. So one of the tenets of CRP is to challenge your students to assume that they can reach these lofty goals. And so we do that in one way by including actual research. So this was a paper that came out in 2016. We took some of the images, we spruced them up a bit, and kind of matched our artistic style. And so they're actually learning about publications, and we tell them that. So we're taking actual state-of-the-art research discoveries and embedding them into the story themselves. And then we also have loads of activities, so they're always looking at trends, looking at patterns, and getting to know more about their world in new ways that don't traditionally show up in these educational processes. I'm gonna skip this bit because we're basically at time here, and just. There's like a scroll to skip things. Okay, so there's a complementary kit that takes that story, it comes out of the storyline. It's using a prop that's in the story and then literally bringing it to life. So there's a mod capsule in the comic, there's a mod capsule that's in real life. They build a device, they explore with it, they do experiments with it. And so together we're using project-based learning, which has demonstrated efficacy and interest in marginalized groups in particular, and we're using comics as our kind of test. We don't really know how comics work. We know how project-based learning works, so we're trying to do this comparison to see, okay, well, what are the strategies that are most effective for marginalized students? And so we're using storytelling. We're taking practices, STEM practices, and embedding them in the story. So we have experiments that come from and are in the storyline of the comic. And then we have authentic experiences as well. We're showing them actual scientific research so they can understand actual scientific research. And then their experiments have no right answers. So instead of doing an experiment and then checking, they get the wonderful experience that we all have of going, I don't know if I'm right or not. We're actually letting them have the full-blown experience of scientific research. And so we're currently soliciting participants. We're looking to have about 75% of participants with a marginalized identity. And so with this, we'll basically break it out into 4 groups: control, where they don't get any kits or comics; 1 where they just get comics; 1 where they just get the kit; and 1 where they get both. And that way we can compare storytelling, project-based learning to no intervention at all, and see what is actually impacting a number of different things. So STEM identity, how well can you recognize that you're doing scientific or engineering or mathematical things and feel capable of it, that's self-efficacy, and of course a sense of belonging, which is a whole other long-winded talk that I'm not going to give today, but it is something we're moving toward measuring. And so altogether, I'm using storytelling and then testing out applications of art and culturally responsive pedagogy to see if we can address these issues of inequity and interest and engagement in marginalized people in general. So we know that we've loved snakes for a long time. We're obsessed with them. We have these things that transcend culture. So snakes and stories are among them. We're using them to fight this inclusive problem, the achievement gap issue, and potentially doing it using comics. And if you'll bear with me, I can take you through some tips on how you can communicate research. When I've gone to workshops and discussions on science communication, they're like, just get it. And I'm like, that's not gonna help. So I'm gonna give you some tools that will actually help you in the methodology, the actual practice of how you communicate research. Whenever you tell a story, and this counts when you're giving a talk, it counts when you're writing a paper, it counts when you're writing a grant, anytime you're communicating information, we are naturally telling a story. And good stories, the captivating stories, will take you on an emotional journey. I took you on one today. I did this where you start off neutral, don't really know how you're feeling, and then there's a swell of emotion. This could be positive, it could be very excited and anticipatory, it could be negative. There's a conflict, I don't know how we're going to get out of this, but there's some increase of emotion. At the peak of that emotion, that's your climax, that's your main point, that's the most important thing you want somebody to remember. And then quickly after that, you just tie everything up and resolve and get out, right? So the key to setting this structure up is to think of 3 things you want your audience to remember about your work, maybe 2. You take those 3 things and you establish them along this storyline, right? So the thing that is most foundational, the thing you need to understand the most to get the rest, that comes first. The big success that you came across, the big conflict that you're dealing with, that comes second. And then what does that success bring you? What was that outcome? What was the resolution of that conflict? That's the third thing. That's your peak. That's the most important thing, right? So you put that along your storyline, you use that to motivate some emotional response in your audience. And just remember that if you're talking in an inclusive way, it's never just about your research. I know that probably scares the bejesus out of some people, but you are most important in telling your story. We're never out here, I mean, scientists love to think that we could like push ourselves into a box and make ourselves into robots. We're terrible robots. We're wonderful humans. So bring that humanity, bring yourself into it, because that's going to be a way of bringing your culture into it as well. And how we tell our stories is how we define who is in our community. When I start my story, how much detail I give you about the background before I dive in. If you don't know my friend Joe, I gotta tell you about my friend Joe first. But if you know Joe, I'm just gonna tell you what he did, right? And then the most important thing is to participate in your community, right? It's not just the silo of the people that are around you that you see every day. It's the people that you see at the grocery store, on the buses, the people that you bump into. If you're not sure where to go, where to begin, libraries. Public libraries are this huge multicultural resource. People who don't speak English are likely to find resources there. People who have neurodivergent children are likely to find resources there. Low-income families are going to find resources there. It is a huge hub of all these different people, and it's free and it's accessible, and they're always looking for interactions, materials, people to come in and help them out. So make sure that you're active in your community and connect with the people that you're talking to, get to know your audience. So I'll leave it at that. I'll put this up so you can, or I could send this out actually if y'all want. But there's just some general practices. And just to give you a quick digest, if you're looking for resources and you're really like, okay, how do I actually dig into this? Universal Design for Learning, phenomenal. Also another proven, these two have been around for about 20 years and are doing the most measurable improvements in education and just resource access as well. So yeah, so I'll leave it at that. That's really all I have. I'll leave it with this quote that it's one thing to be welcomed, it's another thing to be considered, right? I can invite somebody to dinner or I can make a meal for that person. There's a difference there. So what we're trying to get to is how do we embed these practices where we can consider as many people as possible. So thank you for your time. Thank you for your attention. This is really awesome. I really have had a great time being here. I just want to give some shouts to my really fantastic research team. I love the heck out of them. They're really kicking ass. And also to the Soha Lab, which is my postdoc work. So thank you so much.
Thanks. We might have time for like one question. Does anybody have any questions?
Okay. So our lab this last actually Thursday, we talked about like why do you do science and like what does it mean to you? And I'm thinking of a different question for you was like why comics? Why is that what you chose to like bring out and talk to people?
Yeah, so it was a shower idea. I just the idea came and I just never stopped thinking about it. I am a noob to comics. I got into it in my adulthood, and I say in my past life I was an artist. I did a lot of visual art, drawing, watercolor, digital drawing, and it was kind of a way of merging all of the interests. I love to produce, I love to create, I love science, I like to talk about science, and it just was this beautiful marriage of all of the things that I love and have expertise in.
Okay, do we have any questions online? Is there one more question? Okay.
So I guess like your research with snakes, like snakes are really charismatic and like you said, it's like really interesting or really easy to get people like interested in snakes, even if they don't necessarily like them.
Yeah.
Do you have advice for people that maybe work with systems that are a little less charismatic and a little harder to get like like elementary school students excited about just like cells.
Yeah, yeah, absolutely. So first, this is where you as an individual has a lot of weight. So a lot of people, if you can show your enthusiasm, people will hang on and bear with you if you're as willing and if you have that excitement. When it comes to the more, the less attractive or like more boring things, get to know your audience, right? What are their values? Or that's the key appeal. So if they're kids, maybe they're curious about interactions in nature in a general sense, and so you kind of speak on that level. Or if they're adults, maybe they have like gut problems, and if you're studying bacteria, that's something that's happening inside of your body. So there's ways that you can kind of tilt and apply your science, not necessarily like, oh, I'm gonna only talk about, gut microbes when I don't really study gut microbes, but just to say this is similar to something that's happening in your body. So things around health, things around that weird gap, like showing that there isn't a full story. So there's this, but now I don't really understand how we get over here. Right. Demonstrating those gaps of knowledge are really great ways to like pique just very innate curiosity. We really like to fill in gaps. Our brains are built to fill in gaps. So if you can show them this gap, even if it's something boring, for at least a beat along with your excitement, they'll be hooked. But the big thing is just knowing what their interests are, knowing what they value.
That's wonderful advice. I think a lot of us could use that in our next close. Do we have any more questions? If not, do we have another question?
I have a question, but I can wait till later.
I mean, so you talk about comics and merging like one of your hobbies of like drawing and art. You're also a singer. Have you done any science songs?
Not
Yeah.
exactly. We are making, so one of our kits that we're developing now is a model of the cochlea. And we're making an instrument to represent that because it's tonotopic, so as it moves along in the cochlea, there's different frequencies. And so it's making this tie between making music and how our brains actually literally are making music as we're processing sound. There's always an app sticking it. Oh, it's always one other thing.
I have a question, but I don't know if
Let's see. We should head over to a lunch. Are you guys for lunch together?
Yeah.
Okay, we can talk about we'll have
This is my business card, all of my contacts and stuff are on there. If you wanna grab that, or I'm on Twitter, the.z, DOCPA. And that's probably the best way to reach me. I'm terrible with email.
Well, with that, let's take a moment to thank Shaz for the wonderful talk.
Okay.